I just almost finished making this video. I thought somebody was knocking on my door, stopped the video, nobody was there. So let's start over. Okay, so this video is, let me see. It is the 1, 2, 3, 4, 5, 6, 7. This is the 8th video in the series about fractions. So what we're getting ready to embark on, if you want to be a little dramatic, is adding and subtracting fractions, okay? So what I'm going to do is I'm going to make a video on adding fractions and mixed numbers with the same denominator. I'm going to make another video on adding and subtracting fractions with, not adding and subtracting fractions with the same denominator. Lots of examples, so you can really master that. And then once we can say that we're really good at adding and subtracting with the same denominator, then we're going to move to adding fractions and mixed numbers with different denominators, and then subtracting fractions and mixed numbers with different denominators. So this whole idea of adding and subtracting fractions is actually going to be 4 videos in the series, okay? Most of the time when people say they hate fractions, it's adding and subtracting, okay? It's not that hard. It gets a bad rap. We're going to take it step by step, make it as easy as possible, okay? So again, this video is just going to be on adding mixed numbers and fractions with the same denominator. Let's see here. Okay. So adding fractions and mixed numbers with the same, or what we call common denominators. Okay. So one thing that you must know about adding and subtracting fractions is you have to have the same denominator. This is wildly different than multiplying and dividing fractions. When you're multiplying and dividing fractions, you don't have to have common denominators. And with multiplication, you start right off the bat by simplifying. You divide out common factors top to bottom, you multiply across. With division, it's almost the same thing. You just have that added step of converting to multiplication. Then you cancel common factors and you multiply across. Adding and subtracting, completely different. So with adding and subtracting, one, you have to have common denominators. So we're going to start with fractions and mixed numbers that already have those common denominators. And we're going to master this first before we tackle that adding and subtracting with different denominators where you have a few extra steps, okay? So if I had the fraction a over b, and I wanted to add it to the fraction c over b, first note the denominators are the same. And when that happens, you add the numerators and you keep that common denominator. So as long as your numerators, or as long as your denominators are the same, you add the numerators. You keep the common denominator. And then another thing that's so different about adding and subtracting versus multiplying and dividing is that you simplify at the very end. So you simplify last. So I'm going to capitalize last. I'm going to underline it. I'm going to put an exclamation point. And then just to be extra dramatic, I'm going to put a red star. You simplify at the end. If you have a fraction that could be simplified and you go ahead and simplify it, you just added extra work to yourself, because then you no longer have common denominators. So you're going to have to go through the steps to get the common denominator, then you can do the adding, okay? So simplify at the very end, okay? So let's look at lots and lots of examples. I have 1/8 plus 3/8. I have common denominators, so according to my steps, I could add the numerators, keep the common denominator. 1 plus 3 is 4. So I get 4 over 8, and then I want to reduce. You may need to go back and refer to the video on simplifying fractions, but basically you look for common factors in the numerator and denominator that could be divided out. 4 and 8 have a 4 in common, so 4 divided by itself is 1. 8 divided by 4 is 2. The final answer here would be just 1/2. All right. Let's look at 12/17 plus 9/17. All right, again, I have common denominators of 17, so my final answer is going to be something out of 17. 12 plus 9 happens to be 21. And at this point, 21 has factors of 7, 3, and 21. None of those factors divide into 17. So my final answer really could just be 21 over 17. Now, there are times where it would be good form to write your answer as a mixed number. You never have to write your answer as a mixed number unless directions specify. So right here, 21 over 17 is fine. The improper fraction is completely okay. Times where you would want to consider writing your answer as a mixed number would be word problems. Anytime you're doing measurement conversions or geometry, the mixed number makes more sense. Just same as word problems, the mixed number makes more sense. If directions specify that you need to convert your answer to a mixed number, of course, you would want to do so then. And then finally, if you start with mixed numbers, it's often good form to end with mixed numbers. Here, 21 over 17 is fine, but let's say you wanted to go ahead and convert, you could. The way we convert is we ask ourselves, how many times does the denominator of 17 go into the numerator of 21? Well, 17 goes into 21 one time, and I have 4 out of 17 parts left over. So either answer is perfectly acceptable. Again, I told you a few times where it might be better to use the mixed number, but here, either's fine. What if I had 4/9 plus 8/9? Okay. Just like the previous two examples, I double check. I make sure I do have common denominators. I do. That's the 9. So my answer is going to be something out of 9. 4 plus 8 would be 12. I know right off the bat, 12 and 9 have a 3 in common. So I want to divide out the 3. 12 divided by 3 is 4. 9 divided by 3 is 3. So at this point, my final answer is 4/3. However, it is an improper fraction. So if you wanted to take that extra step, you could say, okay, 3 goes into 4 one time with 1 out of 3 parts left over. Either answer is perfectly acceptable. All right, let's do one more with just 2 fractions. Then we'll look at a few examples where we have 3 fractions. The process is the same. You just have an extra numerator to deal with. Okay, let's say I have 15 over 50 plus 13 over 50. Okay, so a lot of you are going to notice right off the bat, 15 and 50, they're both divisible by 5, okay? If I were to take 15 over 50 and reduce it, I would end up getting 3/10. And if I were to take 3/10 and add it to 13/50, I no longer have common denominators. I can't add that. You can only add when you have common denominators. So this is why we tell people you simplify last. If you simplify at this point, you do yourself absolutely not a shred of good. So we don't simplify. Instead, we add our numerators. 13 plus 15 is 28. My denominator is going to stay the same. And then I want to reduce 28 over 15. So you want to look for any common factor. If you get the greatest common factor, that's awesome. If not, just you keep dividing until you get it reduced. Here, 28 and 50 are both divisible by 2 because they're both even. So 28 divided by 2 is 14. 50 divided by 2 is 25. 14 and 25 have no common factors, so we're reduced. So anybody that said they hate fractions because of adding and subtracting, you can see at this point, it's not so bad. Make sure you know how to do this where you have common denominators before you attempt to tackle adding and subtracting with different denominators. Bless my heart. All right, let's try a few more. What if I had 1 over 22 plus 3 over 22 plus 5 over 22? Same denominators. So I go ahead and I add the numerators. 1 plus 3 is 4. 4 plus 5 is 9. I get 9 over 22. And if I look at 9, factors of 9 would be 9 and 3. 9 and 3, neither one of those will go into 22. So this is actually my final answer. Okay, let's try another one. Want to make sure we get lots of practice with this. So 6 over 35 plus 3 over 35 plus 5 over 35. 5 over 35 plus 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 5 If you look at 5 over 35, you can see that that fraction definitely reduces, but do we want to reduce it? Absolutely not. We don't reduce until the very, very end, okay? So we go ahead and add our numerators. We know we're going to get something out of 35. So I start with 6 plus 3, I get 9. 9 plus 5 is 14. I now need to reduce. So I noticed pretty quickly that 14 and 35 both are divisible by 7. So I want to divide both of these by 7. 14 divided by 7 is 2. 35 divided by 7 is 5. So my final answer here, 2/5. All right. Let's do another easy one. 21 over 75 plus 13 over 75 plus 6 over 75. We've got those common denominators, so we know our answer is going to be something over 75 to start. If you need to do a little side work for the addition of the numerators, do it. It's no big deal. 1 plus 3 is 4. 2 plus 1 is 3. Add the next numerator of 6. 4 plus 6 is 10. Keep the 0, carry the 1. 3 plus 1 is 4. So that tells me I'm going to get 40 over 75. I see that 40 ends in 0, 75 ends in 5. And if you go back to some of the previous videos about divisibility rules, if a number ends in 0 or 5, it's divisible by 5. So 40 divided by 5 is 8. And let's say you don't know what 75 divided by 5 is. No big deal. Do a little side work, okay? 5 goes into 7 once. 1 times 5 is 5. I subtract, I get a 2. Drop down the next digit. 5 into 25 is 5. 5 times 5 is 25. I subtract, I get 0. I'm done. So that tells me 75 divided by 5 is 15. Final answer, 8/15. All right. Don't ever shy away from this side work, okay? We've become so reliant on our calculators that a lot of times we just can't do some of that mental math. Not a big deal. Just write it out, all right? And if you've got a little board like this, it's easy to get rid of it. It's like it never happened. All right. One more, and then we're going to talk about mixed numbers. So let's say we have 15 over 100 plus 30 over 100 plus 25 over 100. All three of these fractions could be reduced. Now, if I were to reduce 15 over 100, I would get 3/20. If I were to reduce 30 over 100, I would get 3/10. If I were to reduce 25 over 100, I would get 1/4. Do you see what a disaster this would be for us if we had 3 over 20, 3 over 10, and 1 over 4? We no longer have common denominators. So do not reduce at this point. This is bad. Don't do it. Okay. So we go back over here. We've got our common denominator of 100. We want to add our numerators. If you need to do a little side work, no big deal. 15 plus 30, 45. Add 25 more. 5 and 5 is 10. Carry a 1. 2 plus 4 plus 1 is 7. That tells me my numerator is 70. I need to reduce. Both numbers end in 0. That tells me they're both divisible by 10. So 70 divided by 10 is 7. 100 divided by 10 is 10. And my final answer here is 7/10. All right. So keep in mind, we do not reduce first. That would be disastrous. And if you need to do side work, do it. It's not a big deal. All right. So we now can kind of say that we're pros at adding fractions as long as we have the same denominator. Remember, as long as the denominators are the same, you add the numerators, you keep the common denominator, you simplify last. In an example like the second one on this slide, where we have 12/17 plus 9/17, our final answer was improper. That improper fraction is a perfectly fine answer. You could convert it to a mixed number. Times where you would want to consider converting to a mixed number would be word problems, measurement conversions, anything with geometry, if directions specify, or oftentimes if you start with mixed numbers, you want to end with mixed numbers, okay? Which leads us to adding mixed numbers. So adding mixed numbers. And again, just like with the fractions we already did, we're going to have common denominators. So hopefully with the fractions that we've already done in this video, we can see that adding and subtracting fractions is so very different than multiplying and dividing fractions. The same is going to be true about mixed numbers. When you are multiplying and dividing mixed numbers, you have to convert to improper fractions. Okay, so recall when multiplying or dividing mixed numbers, you have to convert to improper fractions. I'm going to change the color of my font. This is not the case for adding and subtracting. Now, you can convert your mixed numbers to improper fractions and then add, but I genuinely don't like to do it that way. And some people are just die hard, convert everything to improper fractions, add, subtract, multiply, divide, whatever the case is, and that's fine. For me, adding and subtracting mixed numbers, when I convert them to improper fractions, sometimes I get numbers that are so big that it's nearly impossible to simplify them or convert them back into a mixed number. So for me, I like to just keep the mixed number. So here's what I do. I keep the mixed number. Okay. I add the fraction parts. I add the whole number parts. And then at the end, I simplify as needed. Now, for the most part, this is pretty straightforward. There is one little thing that could happen where you have an extra step. I'll make sure to show you plenty of examples of that. But for now, let's start with something pretty basic. So let's say that I have 12 and 3/13 plus 21 and 2/13. Okay. Now, for me, this is a step that I just do. It's like kind of my own personal preference. It's not necessarily like one of the steps I would list out, but I do like to write my mixed numbers vertically. So I would go ahead and transfer this to like a vertical setup. I think I like to do this just because when we add or subtract whole numbers, we write them vertically. So same thing here. Okay. I go ahead and I make sure my fraction parts have the same denominator. I have a common denominator of 13. So I go ahead and I add my numerators. 2 plus 3 is 5 over 13. And then I add the whole number parts. 2 plus 1 is 3. 1 plus 2 is 3. And that's it. I would double check and make sure that this fraction right here, make sure it is proper. So that means that the numerator is less than the denominator, and make sure it is reduced. And that's all you got to do. All right. It really is that simple. Whereas let's just pretend that we went ahead and converted everything to improper fractions. So I'm going to use a calculator because these numbers are going to get big. I have 12 times 13 plus 3. So I would get 159/13. And then 21 times 13 plus 2, I would get 275/13. And then if I added my numerators, I would get 434/13, which already, and I'm a math teacher, but already that makes me a little nervous. I'm like, oh, shoot, how am I going to simplify that? Even further, it's going to take a lot of work to convert it back to a mixed number. So this is why I prefer to keep my mixed numbers as mixed numbers. Okay. You ultimately, if you like this method, knock yourself out. Just make sure that you're really good at reducing and make sure you're really good at converting back to a mixed number. All right. So again, this is not my favorite method, but it's a perfectly acceptable one if that's what you prefer. All right, let's look at more examples here. So let's say, and I'm just going to go ahead and write these out vertically because that's my preference. Let's say I have 5 2/9 plus 6 4/9. Okay. Well, I've got a common denominator of 9, so I want to go ahead and add my numerators of 2 and 4. So I get 6 over 9. I want to add my whole numbers. 5 plus 6 is 11. And then there are two things you have to check. You need to look at this fraction 6/9. Ask yourself, is it proper? Because with a mixed number, it's a whole number plus a proper fraction. So make sure it's a proper fraction and make sure it's reduced. It's definitely a proper fraction. The numerator is less than the denominator. And then I want to divide. I noticed that 3 and 9, not 3 and 9, 6 and 9 have a 3 in common. So 6 divided by 3 is 2. 9 divided by 3 is 3. So my final answer is 11 2/3. And that's it. It's really that simple. Let's do another one. What if I had 10 1/8 plus 7 3/8? So double check, make sure you do have common denominators. I do. My common denominator is 8. So I want to add my numerators. 1 plus 3 is 4. I want to go and add my 10 and my 7. I get 17. And then this fraction 4/8, two things you have to check. Is it proper? Yes. 4 is less than 8. Is it reduced? No. 4 and 8 have a 4 in common. So divide the 4 out. 4 divided by itself is 1. 8 divided by 4 is 2. So my final answer here, 17 1/2. That's it. All right, let's try one more like this. Let's say this one we have 36 7/18 plus 40 5/18. All right, I have a common denominator of 18, so I'm going to go ahead and add my numerators. 7 plus 5 is 12 over 18. 36 and 40, I'm going to add. 6 plus 0 is 6. 3 plus 4 is 7. So then I ask myself two things about 12/18. Is it proper? Yes. 12 is less than 18. The second thing I ask myself is 12/18 reduced? No. I notice that 12 and 18 have a 6 in common. So 12 divided by 6 is 2. 18 divided by 6 is 3. My final answer is 76 2/3. All right. It's pretty fun, isn't it? Let's try a couple more. Let's do, I guess, 4 more, and then we'll call it a day. So I have 11 and 5/11 plus 20 9/11. I'm going to go ahead and double check to make sure I have a common denominator. I do. The common denominator is 11. So I'm going to add my numerators. 5 plus 9 is 14. 14 over 11. We'll get back to that. 11 plus 20, 1 plus 0 is 1. 2 plus 1 is 3. Now, in the previous examples, I said you ask yourself two things about the fraction. Is 14/11 proper? No, it is not. Okay, so keep in mind a couple of little things here. A mixed number is made up of a whole number plus a proper fraction. Now we want to make sure our answer is in mixed number format. It's not. So I'm going to go ahead and do a little work. Okay. I'm going to take my whole number and I'm going to add my improper fraction. Okay. And then I'm going to convert my improper fraction to a mixed number. So this is really going to be 31 plus, let's see, 11 will go into 14 one time with 3/14 left over. All right. This is now really easy to add. I just add the 31 and the 1 and then keep the 3/14. So 31 plus 1 is 32. and then I get my 3/14. So anytime you have an improper fraction when you do your addition, it's no big deal. Take the fraction, convert it to a mixed number, add that to the whole number, and then just double check and make sure the fraction is reduced. 3/14, there's no common factors. We are good. What about this one? This one's kind of wacky. So let's say we have 2 3/8 plus 4 5/8. All right. We've got a common denominator of 8. We go ahead and add. 3 plus 5 is 8. So I get 8/8. 4 plus 2 is 6. Now, proper fractions, if we go way back to the very beginning of this series of videos, proper fractions are fractions where the numerator is strictly less than the denominator. Improper fractions are fractions where the numerator is greater than or equal to the denominator. And in the event that the numerator equals the denominator, we get exactly 1. And this goes back even further, like way before fractions. Any number divided by itself is just 1. So ask ourselves, what does 8/8 equal? Well, it equals 1, right? So down here, this is really 6 plus 1, or just plain old 7. Okay? So a couple weird things that can happen, pretty easy to work around. Let's do 2 more. What if I had 8 7/10 plus 11 9/10? Okay? So make sure you've got common denominators. We do. Our common denominator is 10. Add your numerators. 7 plus 9 is 16. So I get 16/10. 11 plus 8 is 19. And we do have that issue here. Remember, there are 2 things we ask ourselves about the fraction when we do this addition. Is it proper? In this case, no, it's not. Also, it's not reduced. Okay? So it's up to you whether you reduce first or deal with the improper fraction first. Doesn't matter. For me, I'm going to deal with the improper fraction first, and then I'll reduce next. So this is really 19 plus 16/10. Okay? So that's going to be 19 plus, well, 10 will go into 16 one whole time with 6 out of 10 left over. So now I add the 19 and the 1. I get 20 6/10. And then I need to double check and make sure 6/10 gets reduced. 6 and 10 have a 2 in common. 6 divided by 2 is 3. 10 divided by 2 is 5. So my final answer is 20 3/5. All right. So the only really weird thing that could happen here is when you do your addition, you're left with an improper fraction. It's pretty easy to fix. Let's do one last example just to make sure we're completely good here. I've got 13 5/6 plus 17 3/6. So I've got a common denominator of 6. I go ahead and add my numerators. 5 plus 3 is 8, so we get 8/6. 13 and 17, I add my 3 and my 7, I get a 10. I carry a 1. 1 plus 1 plus 1 is 3. So at this point, I have 30 8/6. Now, we ask ourselves 2 things about this fraction. Is it reduced? No. Is it proper? No. We have to fix both of those. So I'm going to start with the improper fraction. This is really 30 plus 8/6, or 30 plus, well, 6 will go into 8 once with 2 out of 6 parts left over. So it's really 30 plus 1 2/6. 30 plus 1 is 31. And then we've got that 2/6 still. Now I've got to double check and make sure the 2/6 gets reduced. So 2 and 6 have a 2 in common. 2 divided by 2 is 1. 6 divided by 2 is 3. My final answer is 31 1/3. And that's it. All right. So really quick recap. To add fractions and mixed numbers, you got to make sure you have common denominators. For just fractions, you add the numerators, keep the common denominator, simplify last. For mixed numbers, it's a little different than multiplying and dividing. Anything with adding and subtracting with fractions or mixed numbers is going to be completely different than multiplying fractions or mixed numbers. with multiplying or dividing fractions and mixed numbers. When you're multiplying and dividing mixed numbers, you absolutely have to convert them to improper fractions. With addition and subtraction, you don't. You can, but you do not have to. I prefer to leave my numbers in mixed number format. I add the fraction part, I add the whole number part, and then I simplify. And you always ask yourself two things about the fraction after you do the addition. Is it proper? Is it reduced? Okay. If you get a situation where it is not reduced and it's not proper, you fix it. So kind of like right here, we had 16/10. It's not proper. So we take 16/10, we convert it to a mixed number, we add it to the whole number, and then at the very end, we reduce. So pretty straightforward. Okay. So that's an overview of adding fractions where you have the same denominator, adding mixed numbers where you have the same denominator. The next video is going to be very similar. It's just we're going to be subtracting. So it's almost the exact same steps, except instead of adding numerators, you subtract numerators. And then when it comes to mixed numbers, there's this weird version of borrowing that we do. Okay, so that'll be the next video. And then after that one, we're going to tackle how to add and subtract fractions where you have different denominators. And that's generally what students don't like about fractions. So if anybody's like, oh my God, I hate fractions, that's what they're talking about. It's a piece of cake. We'll get through it. All right. Take care.